Well, I'll assume so.
Right now it's still on your where you need to click on to open the file.
Oh,
Are you sharing your desktop? Yeah, that's what we could see. It's desktop.
all right. I think I double clicked on it instead of clicking share. How about now?
That looks
Yes.
better.
Yep.
Okay. So this is some more. I did. We're going to talk about schematic diagrams now. We talked about a couple of the schematic symbols for diodes and transistors. And I think we did when we did resistors and capacitors. A schematic diagram is used to describe how a circuit works, basically the interconnection of all the components. And we use standard symbols to represent components. So we show the components and their interconnections. Sometimes, I would say usually, it has the type of component and its value, whether it's a resistor or capacitor and what the value is. Sometimes they'll have actual part numbers, but that's not necessarily required. This is a typical real schematic of, I forgot what, some microprocessor little board with regulators and an interface. So what is the name of an electrical wiring diagram that uses standard component symbols?
Schematic.
Everybody should get that one on the test. Bill of materials usually goes along with it, but it's not necessarily part of the schematic. Now, sometimes they'll actually have a little list on the schematic listing all the materials, but that's variable. A connector pinout is just a diagram showing which connector pin is connected to which terminal on the connector. And the flow chart has to do with more software or process stuff than interconnection of components. Which of the following is accurately represented in electrical schematics? Charlie, sounds good. They will not show wire length. And they usually don't show the physical appearance. You'll represent the component with the schematic symbol. Okay. Schematic symbols. We have number 1 is a resistor. 2 is our bipolar transistor. 3 is a lamp, not an LED, just an old-fashioned little, what we used to call pilot light. Used to light up dials on radios in the old days. They're probably hard to find nowadays. 4 is a battery, and we represent a battery with 2 lines. This is a multi-cell battery. A single cell would be the wide line for the positive terminal and the shorter one for the negative terminal. And a ground symbol. And you may see this as this is like an earth ground. Sometimes you'll see a little triangle as a ground. In the case of the exam, they're all going to be these little pitchfork looking things.
And those little arrows are receptacles or
Yeah, but that,
the input.
all right. But that didn't have a number.
I know, I'm just saying. It's a symbol there.
True. So what is component 1?
A
Resistor.
Okay. And these are the actual diagrams you will see on the exam. They'll be on the last page of the exam booklet. So number one is a resistor. What is component two?
Transistor. Mm.
What is the function of component two in figure T1?
C?
B or C? C.
Charlie.
Well, read them. Okay. So component two is the transistor, right? So it won't give off any light that we can see when current's flowing through it. So it's not A. A battery can supply electrical energy. That's number four, but a transistor uses electrical energy. And we don't have a transmitter antenna, so we can't convert any of this energy into radio waves, which leaves Charlie. So this circuit, whatever is on this input terminals, okay, will control the amount of current through that transistor, and conversely the indicator light. So you could say it's a light dimmer. Like if you apply the positive voltage here, it's going to turn the light on, possibly all the way. So what is component three?
An LED lamp.
Okay.
Or is the battery?
Yep, delta.
Okay. All right. Another set. Okay, here we have an AC power plug is number one. A fuse is number two. A single pole, single throw switch is number three. And we represent those. The kind of toggle is the pole, and the other little circle there indicates one of the contacts. So the number of throws is how many contacts it can make. In this case, there's a single lever and a single pole for it to make contact with. So it's a single pole, single throw. We'll see some others like a single pole double throw, or a double pole single throw, or a double pole double throw. And there's even more combinations. Number four is how we represent a transformer. When you see the bars in there, it means there's some sort of medium, iron or ferrite or something, as opposed to just an air core transformer. Five is your diode. Six is a capacitor. We've been through those. Seven is a resistor this time. It was number one in the previous one. We have a light emitting diode, and I don't think I mentioned that. We represent the light emitting diode as a diode with little light symbols emitting from it, as opposed to just a straight diode. It still has an anode and a cathode, and current flows the same way. 9 is our potentiometer. In this case, we're calling it a variable resistor because the center wiper is connected to one end. So it shorts it out as it goes along. So it makes it a variable resistor, which is slightly different than the way we use a potentiometer, even though it's physically the same, could physically be the same device. And then number 10, which is one of those diodes we didn't talk about, is the Zener diode. And it's slightly different in that it has a much lower reverse breakdown voltage. And they can be manufactured such it has a specific reverse voltage breakdown. So you can get one, let's say 5 volts, which means when you apply 5 volts in the reverse direction, it will conduct. And we use that as a form of voltage regulator with a resistor in series with it. It will maintain that 5 volts depending on the total amount of current flow or voltage drop across this. Okay, so what type of switch is represented by component 3?
SPST, that was. Oh, that was.
Alpha.
Alpha sounds good. I added this little chart to show what the symbols are for a lot of these other type of switches. Sometimes you'll see it like this as opposed to a little lever. This is a single pole double throw because it can go to this position or this position. This is a double pole single throw. It's like 2 switches in parallel, 2 single pole single throw switches. And then we have a double pole double throw. Again, it's 2 parallel single pole double throw switches. So what is component 4?
D, transformer.
Okay. So we'll talk about rectifiers, which is one of the ways we use a diode. And some of them are manufactured as rectifiers. It's still a diode, but they're usually more power, set up to handle, usually have either on a heat sink or part of a heat sink so they can handle much more current. And we use it in the form of a rectifier to convert alternating current to direct current. So since it will only conduct from positive to negative, okay, in this circuit down here where we have the transformer, we put a diode in the output circuit and a load resistor, and we've got an AC voltage coming in. So we've got an AC voltage coming out of the secondary of that transformer. It might be more, it might be less, depending on the turns ratio. And as you can see, in this case, it was like a 2-to-1. So the voltage peaks coming out are twice what's going in. So that's the gold versus the blue. Okay, so it's going to pass that positive going cycle, but it's not going to conduct for the negative. So what we're going to see is this pulsing DC waveform. It's going to go from 0 up to whatever the peak is, back to 0, stay at 0 for the negative half of the cycle, and then go back again. So it's no longer an AC waveform, it's pulsing DC because it never crosses 0. And in fact, it never, because of the voltage drop across the diode, it never actually gets there. But it's too small to see that difference. The other part of that circuit was a transformer. Like we said, a transformer transforms, but there's no gain. So it can increase or decrease voltage or current, or in some cases, as an isolation transformer, it would be 1-to-1, but you have no electrical connection between the input and the output. It's strictly a magnetic connection. So you can isolate your house AC voltage from whatever's on the secondary through that transformer. They don't have a common ground. You're less likely to get electrocuted that way. So it can be used as a step up or a step down or isolation. And the turns ratio is what determines whether it's a step up or step down or an isolation. And it's the ratio of the number of turns on the primary versus the secondary. And there's nothing magic about primary and secondary. I mean, if we could flip this around, we call this the primary, this is secondary. It works the same way, except the turns ratio is now just the opposite. It's shown here with more turns on the primary than on the secondary, which means the secondary voltage is going to be smaller than the primary voltage by that ratio. So if it was twice as many turns here as there were here, then the voltage I'm going to see is half of what I put on this side. So what component changes 120 volt AC power to a lower AC voltage for other uses?
Transformer.
Which of the following devices or circuits changes an alternating current into a varying direct current signal?
Rectifier.
Rectifier. What is component 6 in circuit T2? That's from last week. Capacitor, bravo. In a circuit like this is usually called a filter capacitor, and it will be fairly large value in order to basically integrate out those DC pulses to an average DC waveform. What is component 8 in circuit T2? Our special little LED that we can see inside of. What is component 9?
Resistor. Oh, variable resistor.
Right. All right, another set of schematics. Here we have a variable capacitor, number 2, a variable inductor, number 3, and an antenna, number 4.
There's a 1 here, but there's not a 1 on that side.
Huh?
There's a 1 right there, but there's no 1 over there.
Oh, okay. I don't know why they did that. I didn't do it. It's the FCC's diagram. This little break here means it's connected to something over there. I have no idea what. Maybe it's the resistor. But it's not one of the questions.
You left the 1 off for me.
So what is component 3 in circuit T3?
Doctor.
All right. They're not as common as variable capacitors. What is component 4?
An antenna.
An antenna.
That's an easy one. Yeah. Looks like it is. I mean, it looks like what it is.
Well, capacitors look like what they are. They're parallel plates.
Well, that's true.
And inductors look like coils of wire. They used to draw them when actually you could see the coil, but they cheat on these. Okay, so we learned that schematic diagrams are used to show the interconnection of components using standard symbols. And I tried to list all the standard symbols here. It was hard to find these on the internet. Transistors are used to control the flow of current, either by means of a current or a voltage control signal. Switches, we've only talked about single pole, single throw switches. I think a single pole double throw comes up later. Diodes are used as rectifiers to convert alternating current into pulsing DC current. And transformers are used to convert AC into a different voltage depending on the turns ratio. And transformers only work on AC. It requires a changing magnetic field in order to induce current on the secondary winding. Maybe that's time for the demo.
Would be.
So we'll see